Okay, so today we're going to review the lecture from class on Wednesday, which was 2.5 and 2.6. We're going to be discussing linear equations, graphs, and functions, function notation. Okay, so for 2.5, our objectives are to define and identify relations and functions defined in the domain and range, identify functions defined by graphs and equations. So the first problem we have here is we are told what a relation is. A relation is any set of ordered pairs, and then we have a nice example to go along with it. So for exercise 1, we want to write the relation as a set of ordered pairs. Typically, we're looking at the x's in the first column and the y's in the second column. Okay. So to write this relation, apologies, still getting used to the new pen. We're going to take 2010 and it's going to go with its counterpart 2.79. Okay, and we do this for each point. 2012, 3.64. 2014, 3.37, and finally 2016 and 2.14. Okay. Excellent. All right, if you have any questions with that, you can rewatch it. Basically, you want to pair the x's and the y's together and just make your ordered pairs. On this side, we're told that the definition of a function is a relation in which for each distinct value of the first component, so the x's, of the ordered pair, there's exactly one value of the second component, so the y's. In other words, we cannot have the x's repeating. So for A, the best thing I can do for you guys to visually see A is to draw it out. Okay, so we have 1 and 5. We're just gonna say that's 5. Okay, then we have 3, 5, and then we have 5, 5. So 1, 3, 5. You can see if we drew a vertical line through each area on the relation, that we actually have a function. So this is a function. It's a function because it passes the vertical line test. Okay. Now, the second one, what do we notice here? We have a -1 in the x and a -1 in the x, but the corresponding y's, we have a -3 and a +6. So if we drew that out, We'll say this is -3 and this is +6. What do we notice if we draw a vertical line here? Okay, it's hitting twice. That means that this function, this is a relation. Apologies, guys. This is a relation because it fails the vertical line test. Okay, and you could throw on 0 too. It doesn't affect it, so, right? Okay, so all you really need to get from this slide is that we have an input here. The input goes into the function. Into the function. And then you have your outputs. Okay. The set of all values of the independent variable x. So all possible x's will be included in the domain. And you're going to understand what we mean by that in a minute when we look at some examples. The set of all dependent variables are going to be represented in the range. So what you guys need to remember is that independent, think of input. So those are your x's. And then dependent variables are your y's. So they're dependent upon the x, and you will find those in the range. Okay. All right, so here's our example. Give the domain and range of each relation. Determine whether the relation defines a function. So for part A, the question you want to ask yourself is, what are my x's? So and then you'll put your x's in your domain. So you have a 2, and a 4. So you could say 2, 2, 4, or you could just say 2, 4. Doesn't really matter because the 2 is there twice. Now you want to know your range. So you're looking for your y's. And that's going to be 2, 5, and 8. Okay. Please notice here that the 2 is coming from the y and not the x's. And the reason why we have to list out all 3 is because none of them are repeating. What you do need to realize here, though, is that really you could write this as 2, 2, 4, and then you have 2 x's that are repeating. You can also tell this by the fact that you have 2 x's to 3 y's. So we conclude here relation. Okay. You can determine right away if the second one is a relation by looking to see if you have any repeated values. You actually don't have any repeated values in either side. So you have a function. And just to be thorough and get all of your points, you need to say that the domain is your set of x's. So that would be 5, 10, 20, and 40. And your range is your set of y's. And they're going to be 50, 100, 200, and 400. Okay. Don't forget that as you're going through these, you probably want to pause the video before I go over the question and see if you can get it right. Okay. So this is what we're talking about when we say the part where we say you want to list all possible values for the x's and for the y's. What we have here is called a quadratic function or a parabola. The family type has to have an x squared in the function. And the point here that they're giving us, this -3, -2, that is a very special name. It is the vertex. Okay. So if we wanted to determine our possible x's for this point, for this function, I'm sorry, you want to tell me where do you have anything that you cannot have? So in other words, if you look at this function, is there anywhere that it doesn't exist? These two arrowheads here means that it goes on forever. And so any possible x value you throw at this function, it's going to have a corresponding y. And sometimes that you might have two x's that have the same y, and that's okay because the x's will be different. So this function passes the vertical line test. Okay. So the domain here, since it covers everything, is going to be -infinity to positive infinity. The range, however, where do you see the range starting at? Okay, so it comes down here to the point -3, -2, and it bounces. No matter which way you look at this, it bounces. So you can't have a range less than -2. So it includes -2, but it does not go below -2. So then we say that it's from -2 to positive infinity. Okay. Just for some side knowledge, these are called hyperbolas. And we will not get to those in this class. And this is a example of an absolute value. We might get to that. I'm just not 100% sure because I haven't gotten that far in the notes. Absolute value. Okay. Here your author is introducing this idea of the vertical line test. We've already been using it, but I'll go ahead and read it for you anyway. If every vertical line intersects the graph of a relation in no more than one point, then the relation represents a function. What that is saying is if you look at exercise 5, if we draw some vertical lines here, you can see that circles, even though we use them a lot in mathematics, circles are actually relations because they fail the vertical line test. Okay. And any function you would have that would have 2 or more points hitting the line, the vertical lines, is going to fail. Okay. All right. So agreement on domain. This is saying that unless otherwise specified, you don't even really have to think about it. It says the domain of a relation is assumed to be all real numbers that produce real numbers when substituted for the independent variable. So let me give you an example of what that means. If we were to graph A, and we're not going to graph each one of these, but if we were to graph A, we would have negative, we're going to just do it lazy style. So -3, and then we would go up 4 and to the right 1. Okay, so that would be our line. Is there anywhere there that you could tell me we're not going to be? Well, it's a line, so no, the domain, and you can use D to shorten domain, is going to go from -infinity to infinity. The range, well, you can see the range also will span the whole coordinate. So it's also going to be -infinity to infinity. What I will do is, okay, so even though I'm not going to draw out by hand the rest of them, I am going to show you what they look like in something called Desmos, which simulates a graphing calculator. So I've already typed them out, but we're going to look at them one at a time. So this is B, and you can see that B starts at 2 on the x-axis, and then it continues on forever. If we zoom out, you can see that it just keeps going and going and going. Okay, so if we drew our vertical lines there, nope, don't want to do that. Sorry, guys. We'll go back. If you pretend that you are drawing your vertical lines there, you'll see that it passes the vertical line test. So your domain, which is all we actually have to say at this point, is the domain. Your domain is going to go from 2 to +infinity. So and it includes 2. We actually don't have to find range. We just have to state if it is a, so this is extra. We just have to state if it's a function or not, and we already discussed that this is a function. Okay, we know that A is also a function. Okay, so C, let's go back into Desmos and take a look at how we can figure out our domain. So we're going to turn off B and we're going to turn on C. Okay, so again, you can notice if you draw your vertical lines, they're going to pass. But what you need to notice here is that you come really, 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 really close to 2. See, you're coming really close to 2, but you are never crossing it. Okay, so although this is a function, it is not crossing or touching the 2. So This is definitely a function, but your domain is a little bit interesting. It's going from negative infinity to 2, approaching 2, but not touching 2, and then going to positive infinity. Okay. And then the last one, D. This one's very interesting for us to look at. So turn off C, turn on D. Okay. What we have here is an inequality. And you can see that it's been graphed. But what I want you to look at, and this can take a little bit of abstract thinking, I want you to start doing your vertical line test, and you're going to notice that because of the shading, we have multiple hits, like many hits for each vertical line. So that means that we have a relation. Okay. However, we still have a domain of all real numbers. Okay. That inequality doesn't go away or say that it can't be something. So this is just a glimpse at what you guys will be working on if you decide to do the bonus for exam 2. It's already up on Canvas, and I will be adding to it. Okay. So that means this is the bonus for exam 2 for section 2.5. Okay, so I'm going to stop the video here, and then I will pick up on 2.6 in a moment.